Hi, this is a brief walkthrough of a personal project of mine called Hypercubulus. It's a work-in-progress Hypercube simulator for Unreal Engine 4 and the Oculus Rift. So I'll briefly demonstrate what I have so far. As you can see, there's a cube here, and this cube is actually the projection of a hypercube, a four-dimensional object, onto a 3-space. Specifically the 3-space with w equals 0, where w is the fourth coordinate of the 4-space in which the cube resides. So I've mapped key bindings to each of the 6 possible 4-dimensional rotations. It turns out that there are 6 because rotations in general are defined as planes, not axes. So as you see, when I get into some of the more 4-dimensional rotations, the cube appears to deform in an interesting way. The cube actually isn't deforming, though. The 4-dimensional one, rather. Only this 3-dimensional projection is, as the non-deformed solid cube rotates through a 4-space. So how this actually works, I'm calculating the vertices of the hypercube by just taking each possible combination of -1 and 1. Since there's 2 to the 4, that'd be 16 vertices. I'm taking those vertices, I'm producing the rotation matrix for the desired rotation based on each of these key bindings. There's a paper called Generalized N-Dimensional Rotations that has a little blurb in its related work section that I'm using with the formula for that in it. I'm taking the convex hull, then, of those points projected onto the 3-space by simply chopping off the w-axis. For that, I'm using a computational hull library that was included in a book. That book is titled Computational Geometry in C, and it's by Joseph O'Rourke, so credit goes to him for convex hull, which I was not really feeling like writing. With all that said, this probably isn't what you would actually see if you were looking at a hypercube. That would more likely be the cross-section in the w equals 0 space instead of a projection onto that space. So that's what I'm going to be working on next. All I have to do is take the edges, intersect them with that plane, take the vertices, and run convex hull on those instead of the actual vertices. And then gussy it up with some nice interface and maybe some levers and switches for the rotations instead of goofy key bindings. So that's what I've got so far, and that's it.